everyone, welcome back. Today we're diving into three math concepts: factorials, permutations, and combinations. These are useful when you're dealing with counting problems, arrangements, or probabilities. Let's get started. Factorial. A factorial is just a product of all whole numbers up to a number. We write it with an exclamation mark symbol. So, basically, n factorial is equal to n times n minus 1, so the number before it, times the number before that one, and then keep going until you do times 2, times 1, and then you don't write 0, you just stop at 1. It's a product of 1, 2, 3, and then all the way to the number n. So, for example, if we had 3 factorial, that would be equal to 3 times 2 times 1, which is equal to 6. Or if we had 5 factorial, it would be equal to 5 times 4 times 3 times 2 times 1, which is equal to 120. Another thing about factorials is that it's also recursive, which means, for example, n factorial is equal to n minus 1, so the number before it, factorial, times n. So basically, it's a factorial of the previous number, which is n minus 1, times n. So, knowing this, we can basically say that 4 factorial, for example, is basically 3 factorial times 4. Or 3 factorial can be 2 factorial times 3, and so on. Which means any big number factorial can be expressed in terms of small number factorial. So, for example, 4 factorial can be written as 2 factorial times 3 times 4. This is because 2 factorial is 1 times 2. So it'll be 1 times 2 times 3 times 4. And 4 factorial is 1 times 2 times 3 times 4. So it's the same thing. Now let's look at some special cases. 1 factorial is equal to 1. And this is by definition. But do you guys know what 0 factorial would be? Well, it's a hard guess, but it's not 0. It's actually 1. I can't really explain this, but it's just a special rule in math. But some questions that you might have is, what about the factorial of negative numbers? No, it's not possible. It's not defined. In standard mathematics, the factorial function is defined only for positive integers. This means that the factorial of a negative number is undefined. What about the factorial of a fraction, you might ask? No, in standard math, we only use factorials for positive whole numbers, not fractions. That's factorial. Super easy, right? Now let's move on to permutations. A permutation is an arrangement of items where the order matters. We use this formula for permutations. Another way to write this formula is NPR is equal to n factorial divided by n minus r factorial. And in the formula, the n stands for the total items, and the r stands for the items to choose or pick. Let's take an example. Example 1. How many ways can 3 students line up out of 5? So, over here, we know that our total is 5, so our n is going to be 5, and our pick, or the items to choose, is 3. So our r is 3, which means we can write this as 5p3. And if we wanted to solve this, we can just do this. So this is equal to 5 factorial divided by 5 minus 3 factorial, which means this is equal to 120 divided by 2. And this is equal to 60. So the answer is 60. Example 2. How many 2-digit numbers can we make using digits 1, 2, 3 with no repeats? Okay, so this one's a little tricky. But as you can see, we have our total as 3. So our n is going to be 3. And it says how many 2-digit numbers. So our r is just going to be 2. So we can write it as 3p2 is equal to 3 factorial divided by 1 factorial. 1 factorial because 3 minus 2 is 1. So I just put 1 factorial over here. And we know 1 factorial is just equal to 1. And 3 factorial is 6. So the answer is 6. Arrange the letters A, B, and C in all possible ways. Okay, so let's do this. We know that the total is 3. And we want to arrange all the letters, which means 3 letters. Which means we need to also pick 3. And our total is 3. So we would write it like 3p3 is equal to 3 factorial. And the reason it's 3 factorial here is because on the top we would have 3 factorial, and on the bottom we would have 3 minus 3 factorial. So that just be 0. And we know that 0 factorial is just equal to 1. So on the bottom it just be 1, and yeah. So we have 3 factorial, and 3 factorial we know is equal to 6. So these are the possible combinations in case you were wondering. So our first one was ABC, and then ACB, so we switched these around. And then our other one was BAC, and then BCA, and then we have CAB, CBA. This is how we got our 6. You can also do it manually or using the formula which we used. In permutations, position matters. Changing the order gives a new result. Each arrangement is counted separately, even if it is made up of the same list. Combinations. A combination is when you choose items, but the order doesn't matter. It is always smaller than permutation. We can write it as NCR, and the formula for that is permutation divided by R factorial. So this is equal to the permutation divided by R factorial. Like this. It means combinations count is R factorial, times smaller than permutations. It also means NPR is equal to, so it also means NPR is equal to R factorial times NCR. And the entire formula for NCR is this. NCR is equal to N factorial divided by R factorial times N minus R factorial. This is the formula. We use this formula to solve problems. Speaking of problems, let's do a combination problem right now. Example 1. How many ways can you choose 2 friends from 4? Okay, so to solve this, we can just write 4C2, which is equal to, because we have to choose 4 friends from 2, which is equal to 4 factorial divided by 2 factorial times 2 factorial. And this is equal to 24 at the top. And at the bottom, we know 2 factorial is 2. So 2 times 2 is 4. So we get 4 on the bottom. And this is equal to 6. So the answer is 6. Example 2. From 5 books, how many ways to pick 3 to read? Okay, so now all we have to do here is 5, C, and 3. Because we have 5 books in total and 3 that we picked to read. So this is equal to 5 factorial divided by 3 factorial times 2 factorial. So this is equal to 120 at the top, and at the bottom we get, this is 6 and this is 2, and 6 times 2 is 12, so we would get 12 here, and this is equal to 10. By the way, if you're wondering how I got 3 factorial times 2 factorial here and 2 factorial times 2 factorial here, I just used the formula. I did n minus r, so I did 4 minus 2, which ended up with 2. So this 2 factorial was already here, and then I also got the 2 factorial from the subtraction. Same thing over here. I got this 2 factorial from doing 5 minus 3 factorial. From letters A, B, C, how many 2-letter groups can you choose? Well, I know there's 3 letters and 2-letter groups, so it would be 3C2. This is equal to 3 factorial divided by 2 factorial, and 3 minus 2 is 1, so it's times 1 factorial, the bottom. And at the top here, we get 6, and at the bottom here, we'll get 2, because this is 1 and this is 2. So this is equal to 3. Remember, in combinations, order doesn't matter. A, B, and BA are the same. Also, in case you were wondering the groups for the letters, here it is. It's AD, AC, BC. So, to wrap up, factorial means multiplying numbers in order. Permutation, order matters. Combination, order doesn't matter. Hope this helps you understand these concepts better. Don't forget to like, share, and subscribe for more fun math videos. See you next time. Bye.